Hey you guys, in this video in C++ we're going to cover a new data type called strings. And what strings do in C++ is that they effectively replace using character arrays and read-only strings, meaning creating character pointers and setting string data equal to it. Why don't we take a look at this program I wrote to see where we can go, what capabilities we have with C, and what capabilities we have now when we upgrade, or I say change languages, to C++. So why don't we take a look at the first statement here. Variable statement A is an array of 2 characters. What's the problem with this array? Well, for starters, it doesn't include a null character. It's just H and I. So if I use %s to print statement A, I don't know where it's going to end, because it's lacking a new line character. Statement B is also a string, and in my opinion is the best of the 3 statements. It's a string, it includes the null character, and unlike the next statement that we have, we can edit this. Which brings me to statement C. So statement C is a pointer to a character, but is given string data. Because of this, statement C is a read-only string. I cannot edit it. On the bright side, however, it does include the null character, like statement B. So there are some good and bad that come with each one of these statements, mostly bad. However, they all share one same problem. They are all static, meaning that once now that I've created the string, this is their size forever. I can change the data inside of them, well, excluding statement C, but their size is like this till the end of the program. Enter the string data type. In order for us to use string, we need to include the string header file. Now that that's included, we can go about creating the string. So string is part of the std namespace. So in order for us to create a string in C++, we use std : string, and I'll say s. And there's 2 ways of, well actually 3 ways of declaring a string. Here is one. Here is another. And here is the third. So here are 3 ways of creating the strings. Each one of these are valid. However, I will say in lines 9 and 11, these are initialized, while in line 10 it is just declared. So like statement A and statement B, we can edit the characters inside of the string. So I can say something like this. And why don't we go about printing S and S3 since they have values. If you guys are programming along, feel free to use std_l if you don't want to use the \n. Why don't we run this code and see the result? So here we see the result, and actually, hey, look at that. Deprecated conversion. Right, so this is kind of a compiler warning us that this is no longer supported, which is good because we shouldn't be using this in C++ when we have string. But anyways, here we print our 2 strings. Realize that S, when it was first declared, which is being printed right here, was yellow, and I changed the first element of that to H, so now it's hello. So strings, similar to how statement A and statement B were, we can edit the data inside of it. Not only can we print out data like this, we can actually scan in strings, and it's quite intuitive compared to integers and floats. Like, it is as intuitive as scanning in integers and floats. So we will read in S2, and let's print it back out. We'll print S2, and we'll give it a new line. Actually, here I'll use std_l, just to add some variety to the code. Let's see the outcome of that now. Here, std_cin is waiting for me to enter a string, so that way I can give S2 a value, and I will keep it simple. So the way I use strings here should feel now somewhat a little bit intuitive to how we use other character types like integers, doubles, and floats, and singular characters. Right, now that we have this string, we have this data type that's been created that has somewhat the same functionality, right? The idea is that with this data type, you have the same functionality, kind of an intuition that comes with using the singular data types, like, again, integers, floats, and doubles. For me, doing this stuff in C++ or C, I mean, mostly C++, this feels intuitive. This could easily be an integer or a float, and it feels that way. I'm using it that way, right? But in reality, this is a string. And if this was C, well, we need to be doing a lot more things here. We need to do a lot more gymnastics, because the only way we could have strings in C is if it's an array. But here with this specific data type stood string, now we have a singular variable that can hold the place of a string. And what's really nice about this data type is that not only can we treat it as a singular variable as we do here, but we can access it like an array. So we really get the best of both worlds with stood string. And why that's the case, we'll explore when we talk about classes. With the introduction to strings, we actually have additional functionality that comes with the variable. If I'd like to, now I can type something like this, and this is kind of unheard of in C. I definitely cannot do something like that in C without causing a lot of problems, especially this. It's like it's a structure, but I'm trying to access a function inside of that structure. And the reason we can do this is because C++ introduces probably one of the best concepts for a variable in software engineering. And to my knowledge, there isn't a programming language that's come up with a better concept than this, which is called a class. A class is like a structure. It's a user-defined data type, but we have a little bit more functionality. With structures, we can bind variables and to the structure itself, but with classes, not only can we bind variables to our user-defined data type now, but we can also bind functions to it, and this is what's going on here. The function size is binded to the data type stood string. In this context, because this function is binded to this data type, it's called a method. So here I call the size method of S, which is the data type stood string. And because it's a user-defined type, there's been some code here that allows us to resize and give new value to S. So this is all totally valid. And here we'll see the changes in S size for our original data and our new data. You see here now, hello only had a string size of 5, and then S got changed. First of all, we were able to change the data of the string without causing any error. And second of all, this new changed data inside of our string, S in particular, has a new size, and it grew in size by 6 letters. This is really neat because this is quite an upgrade from using characters in the traditional sense with C programming. Now, I'd like to show you a program that kind of shows the other methods that are available with the stood string data type. And why don't we call this Str Method Example. And here we are. So we start the program with creating a basic string just called S, and right away I call a method that belongs to stood string called empty. And what this method does is that it essentially checks if the string is empty. We begin the program by creating a stood string called S. Then we immediately check if S is empty by calling the empty method. And what the empty method does, it checks the contents of the string. If there are no contents inside of the string, then we return true, because if there's no content, then it is empty. Otherwise, we return false. So because we're just declaring a string here, this should always print this statement. Next, on line 14, I do something called reserve. So with my string, I'm reserving 5 characters. Now then, I can give these 5 characters values. These 5 values being the capital W, H, A, T, and a question mark. Then we go here and we say stood cout, where we want to find out the length of S. So like our previous program, I called the size method of the stood string data type to get the length of our string. So because we reserved 5 here and we gave it a 5 character string, we should expect 5 here. I use S to clear out the entire data, so it essentially becomes empty. And in a analogous way of checking if it's empty, I check if the size is equal to 0. And if the size is equal to 0, that means there's no content inside of it, meaning it is empty. So why don't we go about running this code? So now that we run it, the program behaves as we expect it to. So we have, because we declared S and we immediately check if it's empty, this should print that this is empty. Then we reserved 5 values for it. We give the string 5 characters. So it makes sense that the length of the string is 5. Finally, we clear the data, and then we check if s is empty. And like it was when we declared it, because we used the clear method, s is empty. If you'd like to know more about these methods and what other methods belong to the string class, a good resource for you to check out is going to be cppreference.com or c++.com. The C++ reference site. What I did is all I did was Google string C++ reference. So it'll give you some stuff that you can call. It says, oh, hey, size, which I hope seems familiar to you, reserve, clear, empty. I hope these 4 names that I just said are familiar to you because we just use them in a function. And we can look at other functions that are available to us. So it looks like length is the same as string. We also have a method called resize that's available to us. We also have something called append, as well as pushback, erase, replace, and swap. And something that's pretty important is a C string. The std string data type is not the same as a C string. So if it turns out you have C++ code and for some reason you need a C string, using this method is a good way of taking a std string and getting the C string equivalent for it. Feel free to come to this website and look at what other methods you can use for this data type. Maybe play with them yourself. But this is it for string. The next video we're going to cover something that will take over arrays, and it's called a vector. So here we have strings which takes over the old C string, and next we're going to cover vector, which takes over and which is an upgrade from arrays.